virulence factors. These are molecules that are part of the organism, or they're made in the organism, or released to the outside of the organism, where they exhibit their pathogenic properties. Organisms that have virulence factors are much more dangerous to us because they have weapons. It's like an arms race, right? Because the microbes have all these weapons and we have all of these defenses. And so we're hoping that our defenses can mitigate those weapons that they have, and they have a lot of them. So we talk about virulence factors. There are many ways to talk about them. I want to talk about them in 4 categories. The first one is structural. So structural means that they're part of a cell or part of the virus load. And these will be, for examples, capsule, or an envelope, or a cyst. There's a whole bunch of them. Right? You can go on and on and on. We talked about these already. The second type are toxins. And there are lots of toxins. And so just to make sure that we don't get all bogged down in toxins, we're going to talk about 2 of them, and they're going to be bacterial. So there's an endotoxin, and then there is an exotoxin. Okay. The third group are the enzymes, and there are many enzymes, right? And you could talk about these forever. My favorite one is this one. Hyaluronidase. How many people have ever heard of hyaluronic acid? Hyaluronic acid they put in makeup and they put in all kinds of things.
Plug the skin.
Yeah, it's supposed to like help the skin heal, fill the gaps, produce more collagen, all this kind of stuff. Hyaluronidase, we'll talk about it in a minute, but it's known as a spread factor for a reason. And the last group are the anti-phagocytic properties. And I could probably call those protein, because there's a couple of them that really come to mind, right? And so that's protein A, which is produced by Staph aureus, and M protein, because, you know, the people who study the strep, they don't want to be like the staph people, they want to do their own thing. So instead of calling it protein M, they put the letter before and they call it M protein. Right, and so the way these things work, let's do the anti-phagocytic properties for a minute, because I don't have a slide for them, but let's just talk about them for a minute. So Ms. Britt will come up here, and I want you to stand right here, and I want you to be a mean-looking phagocyte. I am Staph aureus. The brittle phagocyte is going to try to engulf me, but the problem is, I'm Staph aureus. I have protein A, and so when the lymphocyte gets near me, I don't let them close enough to me that they cannot phagocytize me. So no matter how many times they try to come and get me, it's not going to happen. You're pretty strong. Yeah, it's just not going to happen. It's going to resist. Okay. Now, some people will argue that a capsule is an anti-phagocytic property, and I'm not going to argue that. I think it is, but to me, it fits more with structural. It's part of the cell.
So are the antiphagocytic more like just like a single arm kind of thing out, or is it?
Not really an arm. They're just proteins that they get actuated when something gets near them, and they don't even get near the actual cell.
So it's triggered by them being close.
Protein. What does number 4 say?
Anti-phagocytic property.
And then it's protein A.
An M protein. Yeah. The protein A was discovered first, and it was the people doing research on Staph aureus. M protein was discovered a little bit later, and it was by the people doing research on Streptococcus pyogenes. Okay? So if we think about these molecules, there's a lot of them, right? You can see that there's flagella, there's an enzyme called urease, there's lipopolysaccharides, there's other types of outer proteins, there's secretion systems, there's secretory enzymes, there's a whole bunch of stuff out there that these organisms can produce. And so every organism has its own weapon systems, right? We don't have a lot of weapons, we have a lot of defenses, right? And so we're gonna talk about how our defenses mirror those particular weapons, because it is like an arms race. Every time we find a way to fight them, they change, and then they become stronger, right? And I have a shirt that I wear sometimes that says, "Whatever doesn't kill you mutates and tries again." Right? And that's very true about these organisms. Okay, so if we think about all these things, let's look at toxins. So there are two types of toxins. There's an endotoxin. Endo meaning that, because I'm not going to talk about the structural ones because we talked about them all semester, right? Pick one, whatever is your favorite, right? And since it's going to be all multiple choice, you're not going to have to write it, but you're going to have to recognize it. So, but let's talk about toxins. There are two types of toxins. We're just talking about bacterial toxins. There's toxins produced by fungi, and there's toxins produced by parasites. But we're going to talk about bacteria because they're easy. Okay. So there's an endotoxin, and that means that these toxins are part of the cell. They're inside the cell. In this case, they are part of the cell wall. So it's the lipid A portion of the outer membrane of gram-negative cells. And a little bit of it doesn't do anything, doesn't hurt anybody. But in big numbers, like if it's in the bloodstream, it's problematic. Because the way that the endotoxins work is they cause water to be released from the cells, they cause blood to clot, and they cause fever. Right, so if you think about those organisms that are gram-negative, the principal infection that they cause are all going to be gastrointestinal for the most part. And therefore, when a lot of water is produced, what happens to us, GI-wise? Diarrhea, dysentery. Right? And so those are principal symptomologies of having an infection by a gram-negative organism that's producing a lot of endotoxin. Okay, good. Exotoxins are different. Exotoxins are produced inside the cell and released to the outside the cell. Where the endotoxin, we just talked about, were lipid, these are protein or short peptide. And they all have different mechanisms. And you only need a little bit. So about 1 gram of pure botulinum toxin is enough to kill about 100,000 people, 1 gram. So that's pretty significant, that you have this toxin that in 1 gram, if you had about that much of it, if you dispersed it properly, you could kill a lot of people, okay? But the problem is it takes a lot of skill to actually get that much of a toxin, and not many people can do that, right? Botulinum toxin is more commonly referred to as what? Huh? Botox, that's correct. Botulinum toxin is Botox. We just dilute it in very small amounts. And then it used to be mostly cosmetic. So people would inoculate it around their eyes or around their forehead or around their lips. Like if they were smokers, you know, they have smokers' lips, you know what I'm talking about? So you could kind of do a small injection around the lips and it would paralyze the nerves and your skin would look really great. It didn't have any wrinkles in it. Michael Douglas, anybody know who he is? Yeah, no. Charlie Sheen's father? Okay, no. I'm showing my age, right? There's nobody else. But he tells everybody he uses Botox. And I watched him one time on the late night show. And he was laughing, he was like, you could not see any of his face moving because he uses Botox and he had there was no facial expression. But nowadays, Botox is used for lots of things. Migraines, Crohn's disease, cystic fibrosis, arthritis, just all kinds of stuff, right? So I had a student who came through this course about 3 years ago. 4 years ago. And she already had a job lined up because she had been working for an anesthetist for a long time. And they paid for her to come to school. And when she graduated, she had her job lined up. And all she was going to do was treat people with Botox. That was going to, and she's going to make a lot of money. She was happy. Because she's already good at that. And she had an RN. And they're going to shower her with cash, if you will. Right? I guess they make tips on the side too.
They do.
Yeah, so not only do you make a salary, but if you help somebody look good, they're like, girl, I look good. Here's $20,000. Here you go. I don't know if it's that much. But
That's what I do.
Oh, do you?
That's what I do.
Oh, you might already have a job lined up. Do you know Maya? Oh, maybe I should have said Maya. But all of these have different mechanisms. Some of them are cytolytic toxins. They will break down the cell. Some of them are neurotoxins. They will affect the nervous system. And some of them can be things like emetic toxins, right? What's an emetic toxin? What's an emesis? What's emesis? It makes you throw up. So emetic toxins make you throw up. Food poisoning is an emetic toxin. What's the number one cause of food poisoning? Staph aureus, by far.
Wait, can you repeat the three ones?
The which one?
The three.
So cytolytic destroys cells, right? Neurotoxin affects the nervous system. And then the last one, there's a lot of others, but the last one that I used was an emetic toxin. Okay? Good? So if we look at this chart is really good at showing you the differences. Now, you're not going to have to memorize this chart, but it really helps for you to understand, right? So if we look at exotoxins, they can be caused by gram-positive, gram-negative bacteria. They're metabolites. They're either protein or short peptide. They have high toxicity. You need a little bit, and it can hurt you. Okay? The effect on the host are variable. They all have different sources. They all have different modes of mechanisms of action. They don't produce fever at all. If you have botulism, you're dying, but you don't have fever because it's not an infection; it's an intoxication. Okay.
Would
They
that
have-
be like too much lidocaine?
Too much what?
Lidocaine? Would that be considered like an intoxication?
So lidocaine is lidocaine would be a regional anesthetic. It's not gonna, like if you give it to somebody in the back, it's only gonna do the back. It's not gonna go anywhere else. Right? So too much lidocaine can like really affect like people's maybe mobility, but it's not gonna kill them. I don't think. I've never heard of anybody dying of too much lidocaine. Before the lidocaine, it was called xylocaine. Right? That was strong. And it's not that strong. It has strong antigenic specificity because it's a protein, and because of that, we can denature it and we can make vaccines out of it. Because if it has strong antigenic variability, if it has strong antigenic properties, all vaccines are made against a protein, right? Whatever that protein might be. So there's a very famous vaccine that you take for the toxoid, which is the toxin that has been denatured, and you take the vaccine for this particular toxin. Do you know what vaccine that is?
What was your question?
What is the vaccine that everybody takes that is against a toxin and not against an infectious agent? Tetanus. So tetanus toxoid. Right? It's part of the DTaP. Right? But anytime you're in nature and you have a puncture wound, or what my mom used to tell me, rusty nails will give you tetanus. No, that's not true. Anything that can break your skin can give you tetanus. A piece of glass, a twig, a thorn. When you're a skateboarder and you're going down an incline, you hit a pebble and you slide and you get all this road rash, that can give you tetanus. Because Clostridium tetani is everywhere in nature.
You said it works against.
What it causes is it causes rapid fire of the neurons And so you have this thing called spastic paralysis. Spastic paralysis, in its most deadly form, you get so tight that you cannot unwind. It's just your neurons are just firing all the time. It puts so much pressure on your heart. Usually people are gonna die. They die of a cardiovascular event.
And you get this vaccine.
You get a vaccine, and every time, like you'll get it when you go to nursing school, and then anytime after you get hurt, you should get a tetanus. Now, if you cut yourself at home on a little knife, probably not, unless you're like chopping potatoes or something, right? But if you're out there and you're camping or whatever, and you get into the water and you get stuck on a piece of metal and the metal cuts you, yeah, you should get a tetanus toxoid vaccine.
But like, what does the vaccine work against? Like,
The toxin.
the toxin.
Okay, so you can see a whole host of different organisms or diseases that it works against: botulism, tetanus, gangrene, diphtheria, cholera, plague, and staphylococcal food poisoning. Staphylococcal food poisoning is the most common intoxication that we see as humans. It's very common. What is the most common holiday for food poisoning? July 4th.
Is it the heat?
July 4th. Because that's when everybody's out at the park and it's hot, and Aunt Chema made potato salad, and you know, when she made potato salad, she put snookers in the potato salad, and then it just sits there at room temperature or at ambient conditions, and it doesn't smell bad though. You would eat it because it doesn't smell bad, but it can really make you sick. I guess that means we need to go. So the gram-negative then, it's the lipid A portion and the outer membrane. It has low toxicity, but it can be fatal at high numbers. They all have the same mode of action, right? So they cause fever, they cause you to be kind of, not very active. They can cause blood to clot, and they cause water to be lost. So lots of water gets lost from it, so you get dehydrated. So the one infectious agent that scares me the most, we don't have in the States, but it's in a lot of other places, and that's Vibrio cholera. That can kill you because you lose about a liter of water every hour. So in 3 hour time, you're completely hypovolemic. You have no water, and you go in shock. You can die.
Where do you get that? How do you get that?
As close as Mexico.
Like consuming.
From drinking mostly contaminated water. Okay. But mostly it's you get Caribbean, South America, Asia, Africa, lots of places. India? Yes?
Yeah.
It's a bad thing. It's the number 4 biggest killer of infectious diseases. It's pretty strong. We can't break it down. It's lipid. And if you put it in an autoclave, it doesn't do anything. It just sits there, right? It's not like a protein that you can nature. But therefore, we can't make vaccines. But the types of represented diseases you have are typhoid fever, tularemia, endotoxic shock, urinary tract infections, and meningococcal meningitis. The baddest of all meningitis is this thing that will produce all kinds of problems. Okay, so we're gonna move next door because there's a class coming in here. So you can take another 5 and then meet me over there and we'll finish.